Good afternoon, students. Welcome back to microprocessor and microcontroller online class. We left with the two topics in the second unit. One is USRT, Universal Asynchronous, Synchronous, Receiver and the Transmitter, USRT. And it is an integrated circuit, and the model of the integrated circuit is 8251 USRT, which is used for the serial communication between the input output devices and the processor. In today's class we are going to discuss about the USART, that is nothing but Universal Asynchronous and Synchronous Receiver and Transmitter. It is an programmable integrated circuit. That means according to the user program, this 8251 or USRT is going to support for the serial communication. Then what is the USRT? I am going to explain now. 8251 is, as I said, that is USART, Universal Synchronous, Asynchronous, Receiver and Transmitter for the serial communication. Serial communication is nothing but bit by bit is nothing but serial communication, whereas parallel communication is nothing but byte after another byte is called parallel communication. So that it is a port which supports for the serial communication. As we said, it is a programmable peripheral interface. It is a programmable peripheral interface. That means what? It can be interfaced with the 8086 microprocessor or 8085 microprocessor designed for synchronous and asynchronous serial data communication. That means it is an programmable logic device which is designed for the synchronous and asynchronous serial data communication, and it is nothing but it is one of the peripheral which can be interfaced with the 8086 or 8085 microprocessor. And the need of the serial communication is that serial data transmission or the serial data communication is widely used in the communication over the long distances. That means if you wanted to transmit the data over a long distance, and we can prefer the communication or the data transfer technique is nothing but serial data transmission. Parallel transmission or the parallel communication requires many wires to be laid between the two communication points. That means what? If you wanted to transmit the data in parallel way in between the source and the destination, we have to have the many transmission lines to transfer the data between them. So to avoid this problem, we are going with the serial data communication. Even it is less speed compared to the parallel communication, but the less hardware is required for the serial data communication, serial data transmission, so that serial data transmission can be achieved by making use of the integrated circuit, programmable logic circuit, that is called it is 8251A, that is Universal Synchronous, Asynchronous, Receiver and the Transmitter. Hence usually data is converted into serial format and sent over a fewer number of wires to the destination. As I told just now, the problem of the parallel data transmission, it requires the more hardware. To avoid that one, we are what we doing, we are converting the data into the serial communication or serial format such that can be easily transmitted from the source to destination, and with the very less number of hardware, or with the less size of hardware or the less number of wires, so that the receives the parallel data from the transfer microprocessor. This 8251 8251, it is USRT. It receives the parallel data from the processor, that may be 8086 or the 8085 processor, and transmit serial data after conversion of parallel data to the serial data. Here the important point is that the 8251 supports the serial data communication, but the processor supports for the parallel data communication, so that whatever the data which took by the 8251, it is in the form of the parallel data communication, and so that 8251 is going to convert that parallel format of data into the serial form of data. So that here this 8251 programmable integrated circuits receives the parallel data from the microprocessor and transmit serial data after conversion of parallel to serial. So that this is only the programmable integrated circuit can convert the parallel form of data into the serial form of data. It also receives the serial data from the output device and it transmits the parallel data to the microprocessor. This is another case. For example, in the first case is that the processor is giving the data to this USRT such that it has to convert that parallel to the serial, and that serial will be connected to the input output port. But the second case is that input output port wanted to give the data to wanted to communicate with the microprocessor in a serial manner, so that whereas the processor can have the communication in the parallel manner, so that it going to convert from the serial to parallel data format, and such that here the conclusion is that 8251, it is USRT, that is universal synchronous asynchronous receiver, and the transmitter can able to convert the parallel data into the serial and the serial data into the parallel data. So that this is the things which are very very important in the introduction. That is nothing but USRT stands for universal synchronous asynchronous receiver and transmitter, and it is used for the serial communication. And the problem with the parallel communication, it requires the more hardware and the more transmission lines needed for the parallel communication, and it can convert serial to parallel and parallel to serial. This is about the introduction about the USRT. Then what is the basics of the serial communication? Then we know that the serial communication is bit by bit communication, one after another, that is serial communication. If you transmit the all together at once, that is called it is a parallel communication. The process of sending the data bit by bit sequentially over a single transmission between the sender and receiver. Sender is nothing but it is a transmitter, and it is a receiver is known as the serial transmission of data. We know that it is very clear that serial communication is nothing but sending the data bit by bit. We are discussing this is with respect to the digitals, so that serial communication in digital is nothing but the process of sending the data bit by bit sequentially, one after another. We have sending the bit information over a single transmission lines from the sender to the receiver. Sender is nothing but the transmitter, and the receiver is nothing but it is the destination. Now it requires only one communication line rather than n number of transmission lines data from the sender to the receiver, where n number of transmission lines are required in the parallel data communication, where in serial communication it requires only one communication line, so that the hardware required for the complete communication is going to be reduced in case of serial communication. Next we are going with the another point in the basics of serial communication. For correct data transmission, here has to be some of the synchronization between the transmitter and receiver, so that for example I wanted to transmit the data of 1110 from the transmitter to receiver, so that I have to assure that this 1110 has to be received by the receiver. That means what? For correct data transmission, there has to be some form of synchronization between the transmitter and receiver. Then only there is a correct communication will be possible, or the correct data transmission can be possible. Otherwise, there may be a chance of affecting the errors between the transmitter and the receiver. So that serial communication reduces the cost of an integrated IC package by reducing the number of pins used for the communication between the different ICs instead of using the parallel communication. Already we discussed this one. The serial communication will reduce what? The serial communication will reduce the hardware which are required in the parallel communication. In the parallel communication, we know that it requires the n number of transmission lines for transmitting the n bit of data, so that it requires the more power. It is going to have the more power consumption because the channels are more, so that the power required for the transmission of the data from source to destination is going to be more. And so that here in serial communication, it reduces the cost of the IC also, so that a single IC can be used for the serial communication, and the number of pins also less, so that IC cost will be very less compared to the parallel communication. So that we are going to have the basics of the serial communication. Now I am going to have some more basics of the serial communication. First one is about the bit rate. Bit rate is nothing but it is the number of bits sent for every second is called it is a bit rate, and the baud rate is nothing but number of symbols sent every second. Every symbol can represent more than one bit. Here we are going with the two things. One is bit rate, another one is baud rate. Bit rate is nothing but the number of bits sent every second is nothing but the bit rate, and the baud rate is nothing but a number of symbols can be sent every second. That is nothing but symbol is nothing but it is more than one bit. The sender and the receiver must agree on the set of rules, that is protocols, and when the data transmission begins and ends, and the used bit rate and data package formats, the user and the receiver must agree these protocols. First one is what? The data begin and end, the transmission begin and ends, and the next one is bit rate and the data packaging formats has to be understood by the receiver and the sender. That means they have to agree the protocols of that particular serial data communication. Next one is synchronous and versus synchronous versus asynchronous. We are very aware of this word synchronous and the asynchronous in the digital systems or the digital electronics. We have studied the synchronous counters and asynchronous counters, and with the synchronization of the various circuits, so we have studied the flip-flops with the clock synchronization. Like that, we are very much aware about the synchronous and asynchronous words. Synchronous data transfer is nothing but, here it is very important, here onwards you have to concentrate more. Synchronous data transfer, that means what? This USRT supports the synchronous data transfer and the asynchronous data transfer. So that to understand that one, we must know what is synchronous data transfer and what is asynchronous data transfer. Synchronous data transfer is nothing but sender and receiver use the same clock signals. With the same clock signal can be shared by the, can be used by the sender and the receiver. That means what? And the clock pulses which are used by the sender, the same clock pulses can use by the receiver also. Supports the high data transfer rate. That means what? During the same clock signal only the sender and receiver has been operating, so that it supports the high data transfer rate. And here it needs the clock signal between the sender and the receiver, because the same clock has been using in the sender and receiver, so that it reads this it reads the clock signal between the sender and receiver. And here a master, that is nothing but or one of the senders should provide the clock signal to all the receivers in the synchronous data transfer. Here we are having some set of senders, we are having some set of senders and we are having some set of receivers. That means what? We are having for example 4 transmitters and the 4 receivers. In these 4 transmitter, one has to provide the clock signal for all the remaining 3 transmitters and the receivers in the synchronous data transfer. Here you have to remember the point is that in the synchronous data transfer, transmitter and receiver uses same clock signal. That clock signal has to be provided by the one transmitter, it has to be used by the another transmitter and the receiver. Coming to here, and if you are good at the synchronous data transfer, you can explain the asynchronous data transfer also. Asynchronous data transfer means receiver uses the one clock signal and whereas receiver uses the another clock signal. For asynchronous data transfer, there is no common signal between the sender and receiver. That means what I already explained that for asynchronous data transfer there is no common signal. There is no common signal between the sender and receiver. That means what? The sender will use one particular clock signal, whereas receiver can be used another particular clock signal. Based on these clock signals, it is going to have the data transfer, and there is no synchronization in the clock signal of the receiver and the transmitter, so that it is named as asynchronous data transfer. And the synchronous data transfer means what? There is a synchronization of the clock signal between the transmitter and the receiver, and so that it is named as synchronous data transfer. And whenever there is no common signal is used, common clock signal is used by the receiver and the transmitter, then that is named as asynchronous data transfer. USRT supports the synchronous data transfer and asynchronous data transfer. That means what? If the transmitter and the receivers are with the same clock, then it supports for the synchronous data transfer. If the transmitter and the receiver are with the different clock pulses, clock signals, then that support for the asynchronous data transfer. And the second point in the asynchronous data transfer is that sender provides the synchronization. Sender provides the synchronization signal to the receiver before starting the transfer of each message. That means what? Sender, the transmitter, is going to provide a synchronization signal to the receiver before it start transmitting the signal, so that for example I am the transmitter, I wanted to transmit the signal to the receiver to that particular device, that is CRO, so that before going to transmit my information I am going to send the clock signal, that is synchronization clock signal to the CRO, such that the CRO is now ready to accept my data which is going to be transferred by the transmitter or a sender. Here the point is clear that sender provides a synchronization signal. Sender provides the synchronization signal to the receiver before starting the transfer of each message. The sender and the receiver first need to agree on the data transfer speed. Just now we discussed that is protocols has to be agreed by the transmitter and receiver. That is nothing but what? The bit rate and the baud rate formats, these to be accepted. Bit rate has to be accepted by the receiver and the bit rate has to be accepted by the receiver and the transmitter, so that here the sender and the receiver first need to accept or agree on the data transfer speed. Data transfer speed is nothing but it is a bit rate or the baud rate. Bit rate is nothing but what? The number of bits per in a transmission. In a transmission, number of bits per a second is nothing but it is a bit rate. The number of symbols per second is nothing but it is a baud rate, so that here this one is this bit rate and baud rate must be agreed by the receiver and the transmitter. And by using the asynchronous data transfer, USRT going to have the data transfer rate is very slower compared to the synchronous data transfer. Here the point is very clear that USRT, universal synchronous asynchronous receiver, and the transmitter is used for the serial communication, serial data transfer. That serial data transfer may be synchronous data transfer and asynchronous data transfer. And if the receiver and the transmitter using the same clock with the higher data rate, then that is named as synchronous data transfer. If the sender or the transmitter and the receiver has been using the different clock signal, and that is named as asynchronous data transfer. Whenever the USRT serving the synchronous data transfer, the speed of that data rate is more. Whenever this is serving the asynchronous data transfer, the speed of the data transfer is very less compared to the synchronous data transfer. This is about the synchronous and asynchronous. Synchronous means that in that transmitter and the receivers make use the same clock, whereas the asynchronous means the transmitter and the receiver, that means sender and the receiver, uses the different clock signal. There is no synchronization of speed. There is no synchronization of between the receiver and the sender. This is about the synchronous and other. Definition of serial synchronous transmission. It is very simple. Serial is nothing but it is bit by bit. Synchronous is nothing but both the sender and the receiver make use the same clock signal. And based on these things, you can go with the 4 points. Definition of serial synchronous transmission. Serial is nothing but there is a transmission of the data between the sender and receiver bit by bit. That is named as a serial. Synchronous is nothing but if the sender and the receiver uses the same clock signal for the data transfer, then that is named as it is a serial synchronous transmission. So that assume that it is a sender and it is a receiver. Sender wanted to send the data from sender wanted to send the data to the receiver, and it is the direction of the data flow, and it is direction of the data flow. Then this is the data which has been sent by the sender and it is going to be received by the receiver. Then we are going to the what? As we told in the previous slide, that is synchronous transmission is very speed compared to the asynchronous, because here we have the synchronization between the speed of the sender and the receiver, because they use the same clock, so that there is the synchronization between the sender and the receiver speed, so that synchronous transmission is effective, reliable, and is used for transferring the large amount of data. Communication is performed based on the synchronization signal added to each bit from the sending side. That means what? Here synchronization between the source and the target, that is nothing but destination, is required, so that the source knows where the new byte begins, since there is no space between the data. So that, and it provides the real-time communication between the connected devices, that chat rooms, video conferences, telephonic conversations, as well as face-to-face interactions are some of the examples of synchronous transmission. These are the examples for the synchronous transmission. And in a synchronous transmission, the synchronous transmission provides the real-time communication between the connected devices, chat rooms, video conferencing. All these things are that is serial communication, serial synchronous data communication example. Next one is asynchronous. Asynchronous is nothing but what? This uses one clock and this uses another clock, and so that in between these we are going to transmit the data, and that is about asynchronous data transmission. And here we are going with asynchronous data transmission. That means what? It is serial communication only, serial data transmission only. But this is using one clock signal, and this is using another clock signal, so that the speed of this one is very less compared to the speed of the synchronous transmission. And these two diagrams explains how the data transmission, or how the data can be transmitted between the sender and receiver. And here we are going with in asynchronous transmission, data flows as one byte or a character at a time For asynchronous transmission, a start bit is used to identify the beginning of each character. Start bit, here the start bit is 0, here the start bit is 0, here the start bit is 0. That means what? Start bit is used to identify the beginning of each character, and at least one stop bit is used to identify the end of that character. One stop bit, we are going to define one more stop bit here, which is going to identify the end of the data character. End of the data character, this is known as bit synchronization. So that one we are going to identify the start bit is used to identify the beginning of each character, and at least one stop bit is used. Stop bit, we are going to add one more stop bit. Here this is a start bit, and we are adding one, we are identifying the one stop bit. By identifying that stop bit, we can identify the end of that character. Character is nothing but it is a group of bits is named as it is a character, which is also named as data. So that we wanted to transmit this to from sender to transmitter, and the first bit is start bit, and we are assigning one bit, that is stop bit, so that by verifying these two we can come to know whether the proper data has received by the receiver or not. Effectively, the sender and the receivers are synchronized on a character by the character basis. Asynchronous serial data communication widely used for character oriented transmission, while block oriented data transmissions are used for the synchronous methods. In the asynchronous method, each character is placed between the start and stop bit. This is called framing. This is the framing. And each bit is placed between the stop bit and the start bit, so that each character, that means what, here each character, here to here a character, assume that here 0 to 1 is a character, it is placed between the start bit and stop bit, so that by identifying the start bit is used to identify the beginning of the character. Stop bit is going to identify the end of the character. We can see this type of format, that is framing, in the asynchronous transmission only, and this is less speed compared to the synchronous data transmission. And next one is about how there is a transmission can be possible. There is a data transmission types. We have simplex in the serial data communication only, data transfer only. Simplex, that means what? Communication is possible in one direction only, that is called as it is the simplex. That means what? We can have the transmitter and we can have the receiver. Receiver is going to receive the data, but it is not going to communicate with the transmitter. So that this type of data transmission is named as simplex data transmission. The best example for the TV and the radio. In the TV and radio, whatever the videos or whatever the audio we have been getting in the radio and the TV, we can enjoy those audio and video, but we cannot communicate with that the TV people. We cannot communicate with that whatever the audio, whatever the video we enjoyed, we cannot communicate with them. So that this type of communication is named as simplex communication, that is in the form of only one directional communication. It is one way communication. It is a one way communication. Coming to the half duplex, next one is communication is possible in both the direction, but only one transmitter and one receiver at a time. This is about police radio, is nothing but walkie-talkie. That means what? The one policeman is going to hold the one walkie-talkie, and here another policeman is going to hold the another walkie-talkie. When one policeman is speaking, another has to listen that one, and after completion of his activity, then the receiver has to again start. So that it is a both way communication only, two sided communication and a two-way communication, but at a time one has to speak and one has to receive that. That means what? But only one transmitter and one receiver at a time. That is a police radio, that is nothing but walkie-talkie. First one is simplex, it is one-way communication. and half duplex is nothing but it is two-way communication, but at once only one transmitter and one receiver can be used. And here full duplex, and this is here we are very much focused on the full duplex one, that is nothing but the communication is possible in both direction, and both sides can transmit the receiver and receiver and the same time. This is nothing but it is the telephone. This is nothing but it is a telephone, or it is a video call communication, and it is a phone communication. And the best example for the full duplex is the video call communication, and the phone communication, telephone communication, and it is possible in both the direction. Both sides can transmit and receive the same time, and this is the data communication types. There are three types. First one is simplex, next one is half duplex, next one is full duplex. Simplex is nothing but it is a best example for TV and radio, and half duplex is a walkie-talkie. Full duplex is nothing but it is the video calling in the phones and communication in the phones. And tomorrow class I am going to start the USRT with the pin diagrams and the block diagram and the selection of pins, and I am going to explain all these things. And tomorrow class we are going to complete this USRT successfully, so that this USRT is very, very important, students. Thanks for listening the class. Thank you. Have a nice day.